Hello friends, welcome to our fifth chapter of IPM, that's Indices. I have completed chapter 1 and you can find that in the description box. So let's get started with the Indices chapter. Now we all know that 2 into 2 is 2 to the power 2. 2 into 2 into 2 into 2 will be 2 to the power 5. How many times you will multiply a same number? That number will come to the power of the base number. Okay. 2 to the power 3 will be 2 into 2 into 2. 2 to the power 5 will be 2 into 2 into 2 into 2 into 2 means 2 multiplied 5 times. Same way 3 to the power 2 will be 3 into 3. So in any number, like if we will take example of 3 to the power 2, 3 it is the base which is being multiplied and 2 is the index or exponent that will tell how many times the base number should be multiplied. Okay, the base is multiplied and the exponent will tell how many times the base should be multiplied. So if it is 3 to the power 2, the base is 3, so 3 has to be multiplied and 2 will tell how many times. So it will be 3 into 3, 2 times. Now we all understood this. Now what are the law of indices? There are some law of indices that we have to always keep in our mind while we are solving any problem or equation. Our first law is the product law. What's the product law? The product law is that a to the power m into a to the power n equal to a to the power m plus n. So in this, any number which is having any exponent, if it is multiplied to the same number with any other exponent, it will result to a m plus n. Okay, so a, it is the same number, the whatever numbers are being multiplied, they are same, just the exponents are different. So whenever the bases are same, just the exponents are different in multiplication, the result will be that number and you will add that exponents. How? Like 2 to the power 3 into 2 to the power 5. Here base 2 it is same, just the exponents are different. In the first number the exponent is 3 and in the second number the exponent is 5. So it will result into base being 2 only and the exponents will add 3 plus 5, which is 2 to the power 8. I hope you understood. Now the second law, that is the quotient law. Quotient law is in the division form. am divided by a to the power n equal to a to the power m minus n. So it is just opposite of the product law. In this, again the bases are same, a, just their exponents are different, m and n, and they are being divided. Whenever two numbers are being divided where the bases are same, just the exponents are different, it will result into the base number and you will subtract the exponents. Like 2 to the power 3 divided by 2 to the power 1. Bases are same, 2, 2. Just the exponents are different. In the first number the exponent is 3 and in the second number the exponent is 1. So it will result into 2 will be the base only and the exponents will be subtracted, that is 3 minus 1, that is 2 to the power 2. I hope you understood. Now the third is the power law. What is the power law? The power law states that any base or any number when it is having the double exponent. Now what is the meaning of double exponent? So you can see it is a to the power m and then brackets are there and again to the power n. So there are two exponents. M exponent is only to base a and n it is whole exponent to the a and power m. So in such types where there are two exponents which are separated by a bracket, you have to multiply those exponents. It is a m into n. So you have to just learn these laws. What happens, why, and why does it happen? Now a m to the power n, it results into a m into n. Like a number to the power 3 brackets to the power 5, it will be a3 into 5, which is 15. Now doing it by a number, so let's take example of 2. 2 to the power 2 it is, and then a bracket 5. So what you will do, 2 into 5, that is 2, 10. But now how we can explain this, that why this law is happening? So 2 to the power 2 it is, which is 4. We know 2 into 2, which is 4. Then 4 to the power 5. Whatever the answer is there, it is same as the answer 2 to the power 10. Just check it out and you will see that the answer is same. So you can either do by this method which I told you, but better is that you learn this law. It will be very much easier. Fourth law is any number that it is raised to the power 0, it will be equal to 1 only. Like 8 to the power 0, it will be 1 only. 5 to the power 0 is 1, 6 to the power 0 is 1, 3 to the power 0 is 1, 7 to the power 0 is 1. But how? Now let's take example of two numbers, that is 8 to the power 2 divided by 8 to the power 2. So 8 to the power 2 divide by 8 to the power 2. So first we will do it by the laws. So 8 to the power 2 divide by 8 to the power 2. So by the quotient law, a to the power 2 minus 2 equal to a to the power 0, right? Which is equal to 1. We know it. The fourth law which we learned. Now by doing by simple method, that is a to the power 2 will be a into a, right? Divide by, again a to the power 2, it will be a into a, that is 1 only, right? When we will cut a, it will be 1 only. So we know it by whatever we are doing it by the law and whatever we are doing with the simple method, they result the same. Just when there will be big numbers, you have to use this law. So for that we are learning this laws, and you can do it everywhere. Law 1, law 2. Law 1 we learn the product law, so we can do it by the different method also. 2 to the power 3 into 2 to the power 5. It's easy. We will find out what is 2 to the power 3 and what is 2 to the power 5. That will result the same only. But when they are big numbers like 16 to the power 40 multiplied by 16 to the power 30. So it will be very difficult to find out what is 16 to the power 40, then what is 16 to the power 30. So for that we have to learn the laws. Now the fifth law is that when a is not equal to 0, then a to the power minus m. So here we are having a negative exponent, that is a to the power minus m. So in such cases, whenever there is negative exponent, we reverse the fraction. So it will be 1 divided by a to the power m. Like 3 to the power minus 1, it will be same as 1 divided by 3. Or 2 to the power 3, it will be same as 1 divided by 2 to the power minus 3. So whenever there is a negative exponent and you have to convert it into a positive exponent, or when you have to convert the positive exponent into the negative exponent, so you have to reverse the whole fraction. I hope you understood all the 5 laws of indices. Now let's come to the solved examples. 4 to the power 3 multiplied by 4 to the power 5. So here we can put the product law. The first law that we learn, that is the product law, where we learn that a to the power m multiplied by a to the power n is equal to a to the power m plus n. So 4 to the power 3 into 4 to the power 5. Bases are same, exponents are different. So it will result into the same base, that is 4. The exponents will be added, 3 plus 5, which is 4 to the power 8. I hope you understood. A second question is, express 128 as 2 to the power. So 128 is equal to 2 to the power what? Means how many times you will multiply 2 to get 128. Now if you keep checking, 2 into 2 is 4, then again 2 into 2 into 3 is 8, and then like this, yeah, you will get the answer. But when there are big numbers, you won't be able to do. So for this, we can have a new method, which is factorizing. You can factorize 128. So here it is factorized, 128 is factorized. Right, so you can count the number of 2's, that is 1, 2, 3, 4, 5, 6, 7. There are 7 2's in the factorization of 128. So 2 to the power 7 is 128. Because when we are factorizing 128, we can know that when we are factorizing 128 by 2, we can know that how many 2 are present in 128, right? So from that we can easily know that 2 to the power 7 is 128. Now third question, 2 to the power 4 and 4 to the power 2, are they same? So we can do it like we can find 2, what is 2 to the power 4? So it is 2 into 2 into 2 into 2, that's 16. And 4 to the power 2, it is 4 into 4, which is 16. Now the another method by which we can do is that 4 to the power 2. 4 it is same as 2 into 2, right? 2 into 2 is same as 4. So instead of 4 we can write 2 into 2 to the bracket 2. It will result the same only. Now 2 into 2 to the bracket 2, it means that this exponent 2, it is for the first 2 also inside the bracket and for the second 2 also. So it can be simplified as 2 to the power 2 multiplied by 2 to the power 2. Now by the power law, when bases are same, 2 and the exponents will be added. 2 plus 2, which is 4. 2 to the power 4. So here 2 to the power 4 and 2 to the power 4, they are equal. So we completed third question. Now the fourth question of solved examples. 3 to the power 14 divide by 27 to the power 2 by 3. Now here the bases, they are different. So how we can do then when the bases, they are different and also their exponents are different? So in such cases, we have to change the bases like we did in the third question. 2 and 4, the bases were same, the bases were different. So we just changed 4 into 2 into 2. In the same way, 27. We know that 27, it is equal to 3 into 3 into 3. If you don't know, you can just factorize it and you can find out. You can factorize 27 by 3 and find out how many 3's are coming. We are doing it by 3 because the first base, it is also 3. So 27, it means 3 to the power 3. So it will be 3 to the power 14 divided by 3 to the power 3 whole bracket 2 by 3. Because 3 to the power 3 is same as 27. Now here we know by the power law that 8 to the power m whole bracket n, it will be equal to 8 to the power m into n. So same way it will be 3 into 2 by 3. 3 to the power 3 into 2 by 3. So 3 it will cut because 1 is in the numerator, 1 is in the denominator, and it will result into 3 to the power 2. So 3 to the power 14 divided by 3 to the power 2, it is 3 to the power 12. How? We know the quotient law, a to the power m divided by a to the power n, it is equal to a to the power m minus n. So it will be 3 to the power 14 minus 2, which is 3 to the power 12. Fifth question, 9 to the power 4 by 3 divided by 27 to the power 2 by 3 in the bracket, then into 3 to the power 3 by 2. Again the bases, they are different, so we'll change the bases again. Now again factorize 9. We will know that 3 into 3, it is 9. So 3 to the power 2, it is 9. So we can write 9 to the power 4 by 3 as 3 to the power 2 bracket 4 by 3 divide by 27. We can write it as 3 to the power 3. So 3 to the power 3 bracket 2 by 3 into 3 to the power 3 by 2. Now all the bases are same. By the power law, we know that a to the power m bracket to the power n equal to a to the power m into n. So here we can multiply 2 and 4 by 3, divide by 3 to the power 3 into 2 by 3. So 2 into power 4 by 3, it will be resulted into 8 by 3, and 3 into 2 by 3, it will be resulted to 2. So it will be 3 8 by 3 divided by 3 to the power 2 multiplied by 3 to the power 3 by 2. Again, bases are same and they are in a very simplest form. So we can do the quotient and the power law. Quotient law is for division and we have to first solve the brackets. So we'll do first the quotient law. A to the power m divided by a to the power n, it is equal to a to the power m minus n. So 3 bases same, exponents are different. So we'll minus 8 by 3 minus 2, which is, when you will do your cross multiplication, 8 into 1 is 8, minus 3 to the 6, divided by 3, which is 2 by 3. Or you can do it by the LCM method. You can find the LCM of the denominators and do it. So 3 to the power 2 by 3 into 3 to the power 3 by 2. Now by the power law, a to the power m multiplied by a to the power n, it is equal to a to the power m plus n. So it will be 3 to the power 2 by 3 plus 3 by 2, which is either by LCM or by cross multiplication, 3 to the power 13 by 6. And this is the answer, 3 to the power 13 by 6. Our sixth solved example, 99 to the power 0 multiplied by 999 to the power 0 is what? Now we know that any number which is raised to the power of 0 results into 1 only. That is, a to the power 0 is 1. So 99 to the power 0 is 1 multiplied by 999 to the power 0 is 1. So 1 into 1 is 1. Seventh question, 17 to the power 3 multiplied by 17 to the power 2 multiplied by 17 into 17 to the power 0 equal to 17 to the power what? So we can see that all 17 they multiplied only. So bases are same, just the exponents are different. So we can do the power law, which is a to the power m into a to the power n equal to a to the power m plus n. So it will be the same base 17, just the exponents will be added, 3 plus 2 plus 1 plus 0. When there is no exponent, it is 1 only. Because in 17 there is no exponent, means it is just the 17 itself. And 17 to the power 1 is 17 only. So when there is no exponent, it is termed as an exponent 1. So 17 to the power 3 plus 2 plus 1 plus 0, it is 17 to the power 6. So the box, it is having the number 6. Now we have completed with solved examples. Starting with exercise 5, 2 to the power 2 multiplied by 4 multiplied by 8 divided by 2 to the power 3. Okay, so here again in some numbers the bases are different, so you have to make it the same. 4 we know it is that we know 4 it is equal to 2 to the power 2 and 8 it is equal to 2 to the power 3. So we can rewrite it again as 2 to the power 2 multiplied by 2 to the power 2 multiplied by 2 to the power 3 divided by 2 to the power 3. Now all the bases are same, right? Now 2 to the power 3 is in the numerator also and the denominator also. So when a same number, it is in numerator also and denominator also, we can cut it. So 2 to the power 3 and 2 to the power 3, it will be cutted. So just what is remaining is 2 to the power 2 multiplied by 2 to the power 2. So you can do it. What is 2 to the power 2? That's 4 and 4 into 4 is 16. That is 2 to the power 4. Or by the product law, as we know, a to the power m multiplied by a to the power n, it is equal to a to the power m plus n. So 2 to the power 2 multiplied by 2 to the power 2 equal to 2 to the power 2 plus 2, which is equal to 2 to the power 4. I hope you understood. Now the second question, 3 to the power 2 multiplied by 9 multiplied by 27 divided by 3 to the power 4. So here again the bases are different. So 9 we can rewrite it as 3 to the power 2. 27 we can rewrite it as 3 to the power 3. So it is 3 to the power 2 multiplied by 3 to the power 2 multiplied by 3 to the power 3 divided by 3 to the power 4. Now by the product law, we can, the bases are same and we can add the exponents. So base 3 it is the same, 2 plus 2 plus 3 divide by 3 to the power 4. Now 2 plus 2 plus 3 is 7. So 3 to the power 7 divide by 3 to the power 4. Now by the quotient law, a to the power m divided by a to the power n equal to a to the power m minus n. So it will be 3 to the power 7 minus 4, which is 3 to the power 3. So the answer for the second question is 3 to the power 3. Third question, 4 by 9 to the power 4 divided by 16 by 27 to the power 2. Now here again the bases are different. We have to make the bases same. So 4 by 9 to the power 4, you can rewrite it as 2 to the power 2 divided by 3 to the power 2 whole power 4, because 2 to the power 2 is same as 4 and 3 to the power 2 is same as 9. Same way 16 by 27 to the power 2, you can rewrite it as 2 to the power 4 divided by 3 to the power 3 whole power 2. Now as the exponent 2, it is in both the base 2 also and 3 also. So we can take out one exponent of it. So it will be 2 by 3 to the power 2 to the whole power 4 divided by 2 to the power 4 divided by 3 to the power 3 whole power 2. Now we know the power law, so we can multiply 4 and 2. So 2 by 3 to the power 2 into 4, which is 8. Divide by, now again the power law, the number 2, it is having one exponent 4 and other exponent 2. So you can multiply that, 2 to the power 8 divide by. Now 3, it is having again two exponents 3 and 2. So it will be 3 to the power 6. Okay. Now 2 to the power 8 divided by 3 to the power 8 divided by 2 to the power 8 divided by 3 to the power 6. Now it is in division form. If you want to change it into multiplication form, you reverse the second fraction. So while reversing, it will be 3 to the power 6 divided by 2 to the power 8. Now you can cut 2 to the power 8 and 2 to the power 8. So it will just result into 3 to the power 6 divided by 3 to the power 8. By the quotient law, it will be 3 to the power 6 minus 8, which is 3 to the power minus 2, which is 1 divided by 3 to the power 2. The answer for the third question is 1 divided by 3 to the power 2. Now the fourth question, square root of 9 by 16 plus 0.008 to the power minus 2 by 3 minus 7 by 10 to the power 0. Now whenever there is a square root of any fraction, you have to first find the square root of the numerator, then the square root of the denominator. So square root of 9 is 3 and square root of 16 is 4. So 3 by 4 plus 0.008, you can rewrite it as 8 by 1000 to the power minus 2 by 3 minus 7 by 10 to the power 0. Now as we know, any number which is having the exponent 0, it will result to 1 only. So 7 by 10 to the power 0, it results to 1. Now 8 by 1000 to the power minus 2 by 3. So for this, now the exponent is a negative fraction. So to convert the fraction into a single number, into a single small number, you have to change the base. So 8 by 1000, you can rewrite it as 2 to the power 3 divided by 10 to the power 3. Now 3 exponent is 2 also and 10 also. So you can take it out. So it will be 2 by 10 to the power 3 whole power minus 2 by 3. By the power law, we can multiply 3 and minus 2 by 3, which is minus 2. 3 and 3 it will be cut because 1 3 is in the numerator and 1 3 is in the denominator. So it will be 2 by 10 to the power minus 2. So it will be 3 by 4 plus 2 divided by 10 to the power minus 2 minus 1. Now here is a single number but it is negative. It is a negative exponent. So whenever a fraction is having a negative exponent, you can reverse the fraction. It will have a positive exponent. So it will be 3 by 4 plus 10 by 2 to the power 2 minus 1. 10 by 2 to the power 2 is 100 by 4. So 3 by 4 plus 100 by 4 minus 1. It will be 103 by 4 minus 1, which will be 99 by 4, or in a mixed fraction it will be 24 3 by 4. So the answer for the fourth question is 24 3 by 4. Fifth question, 1 by 4 to the power minus 2. Now of course again there's a fraction which is having a negative exponent. So in such cases you have to reverse the fraction. It will have a positive exponent. Like a divided by b to the power minus 2, it will result to b divided by a to the power 2. So 1 by 4 to the power minus 2, it will result into 4 to the power 2, that's 16. So here we complete a part 1 of indices. So like, share, subscribe for part 2 and further more videos. Comment which next chapter of IPM I should upload. Thank you. Bye.